Hello friends, welcome back to our channel on Average True. So we are in the series of Engineering Mathematics. Okay. So in the last lecture we have discussed about rank of a matrix or how to find a rank of a matrix and what is the definition, different examples we have done. So for now we move to the next topic. It's about lecture 4. It is about system of linear equations. Means linear equations. And again, it will be very simple concept. I will explain in simple terms instead of doing more mathematical. I will try to explain more about practical. Okay. So, as the name suggests, system of linear equations. What is equation? It's nothing but some equations will be there. 2x plus 3y something will be there. And what is the use of solving equations? It is nothing but to find the unknowns. Okay. To find the unknowns, we will solve the equations. And again, the term linear is what? The degree should be the 1. Let's say x power 1, y power 1 should be something. For example, if it is 2x square and 2xy, it's not comes under linear expression. Similarly, 2x square plus 3y square, something like that. These all are not linear, these all are quadratic. Okay, linear means degree should be the 1. Okay, and system. So, what is a system? That step by step procedures will be there. We will see those things. Okay, before going to that, there will be some solution set, I can say that one. So let's say there are two types majorly. One is homogeneous, another one is non-homogeneous. Okay, so in homogeneous, non-homogeneous, sometimes solutions will exist and sometimes solutions won't exist, and there will be infinitely many solutions, unique solution and trivial solutions. All those things will be there. So first, for that I will make one tree diagram so that it will be simple to understand those things. So let's say you are having system of linear equations. Okay, so this is your major concept. So in this again two types will be there. One is homogeneous, another one is non-homogeneous. Okay, so here format will be ax equal to 0, and here it will be ax equal to b. Okay, and again in homogeneous, solutions will exist in two formats. One is trivial, another one is infinitely many trivial. And similarly non-homogeneous, we will get two types of solutions. One is consistent, one is inconsistent. Okay, and again in trivial we will get only one solution. That is, the condition for that is when rank of a will be number of unknowns, then you will get only trivial solution. Trivial solution is nothing but 0 is the always solution. Okay, infinity trivial solution means you will get infinitely many trivial solutions when you are having rank of a will be less than number of unknowns. Okay, and consistent is nothing but rank of AB equal to and rank of A. AB is nothing but augmented matrix. Inconsistent is nothing but when it is not equal rank of AB and rank of A, you will get inconsistent solutions. And consistent again two types will be there. One is unique, another one is infinitely many solutions. And again for unique solution there will be on some conditions like rank of AB equal to rank of A equal to number of unknowns. If it is equal, you will get consistent unique solution. If it is less than, then you will get infinitely many solutions. Okay, so this is a brief about this system of linear equations. Again, for solving system of linear equations, you can use rank concept and row echelon form or row reduced echelon form or echelon form, Gauss-Jordan and Gauss elimination methods. So many methods are there. There are n number of methods to solve system of linear equations. You can use your convenient model, and you want solution in, for example, you are having 3 cross 3 matrix. You want solution in optimal steps, means you want to reduce the calculation, you want the answer. For that you can use any method, you will get same answer. Okay, for that let's see some applications for that. So everyone, you will see like 2x plus 3y plus some xz equal to some number, like let's say, so 2x plus 3y equal to 10, 4x plus 7y equal to 20. Actually, how these values are coming, that is important. Instead of solving those things nowadays, calculators or programming, anyone can do those things. So, but how x and y and some x option 2 and y option 3 and total sum 10, how it is coming, that is important. Now you can formulate here some business example for, let's say two peoples are there. Okay, A and B. Let's say these two peoples are there, they will go for daily work. Okay, so there they are having some x concept and y concept. How this x will come is, so let's say, yeah, how can you, let's say hours versus raw material, for example hours versus raw material availability. Okay, hours plus raw material availability. So total hours, let's say 10 hours, and raw material total availability will be 20 packets. Okay, how these x and y distribute those things. Okay, so in that way you can conclude this type of applications, or else you can use in physics, chemistry, there will be some equations, some chemicals formation, that sum should be this much. And what about trivial solution? So you are getting Ax equal to 0, where you will get trivial solution. Maximum you will use this concept in eigenvalues and eigenvectors. So to reduce the data dimension. Okay. So these are some, you can just Google it, you will get so many applications by using, but in linear programming, means LPP, there will be more applications for system of linear equations. There will be some objective function z, and there will be some subjective constraints plus 2x plus 10y, something like that you will get. Okay, so this is brief about linear equations. Now coming to the some simple examples. First we will see some simple examples, how to solve those things and what are the conditions and how we will get the type of solutions. Then we will move to some difficult examples. Okay, let's say we are having 2x plus y equal to 7 and x plus 3y equal to 4. Okay, now what is the matrix format here? 2 1 1 3, and there will be vector xy, and there will be b matrix 7 4. So it is nothing but non-homogeneous system of solution. So first step we need to do is we need to calculate the rank of a matrix. Let's say rank of A equal to, for two, it is 2 cross 2 matrix. You can go, you can solve by using directly by using that cross method or by substitution method, whatever it is, but I will explain by using rank method. 2 1 1 3 7 4. So clearly you can see that there is no dependency presence here. Okay, so that rank of AB will be 2 and rank of A also will be 2. So you will get unique solution. So let's say now I really want to make this term as a 0. How I can make this one? R2 implies R2 minus 2 times R1. So then what I will get here? 217 will be the same, and here 0, 3 minus 2 1, and here 7 2s are 14, 14 minus 4 is nothing but minus 10. So here my y value became minus 10. So what about x here? So when you see here 2x plus y equal to 7. Okay. And when I substitute y equal to minus 10, x is nothing but 17 by 2. Okay. So when I substitute those things here, what will happen? X is 17 by 2 and minus 3 into 10. Then 30, 17 minus 30 by 2. No, some wrong. We have done some wrong here. Okay. 2 1 1 3 7 4. Where? So but here it will satisfy, no? 2 into 17 by 2 minus 10. So here we are getting 7. What about here? X is 17 by 2 minus y is 30. So why it is not getting equal? 60, 17. There is some mistake here. Let's solve that. 217, 134. X is 17 by 2. And 2x plus y equal to 7 and y is 10, x equal to 17. It's correct only. 17 by 2 minus 30 should be equal to 4. How? And here it is equal. Okay, I will explain this one in the next class, or else I will give you the comment, I will give the description after solving that equation. Let's see one more equation. Let's say we are having x plus y equal to 7 and 2x plus 3y equal to 40. Then again you can see that here you will get unique solution here, because rank of A and rank of AB will be different, same, and it will be the 2. So 1 1 7 2 3 40. So how you will calculate here? So for example, you want to make here 0 and here 1 0. R2 implies R2 minus R1 2 times. So 11701, and it will be the 14 minus 14 0. It is nothing but y equal to 0 and x equal to 7. Okay, see here. So when you substitute here, you will get 0. So but in previous question we have done some mistake or what? I am not finding any mistake, but it is satisfying in one equation. Why not it is satisfying in another equation? X plus y, 2x plus y equal to 7 and x plus 3y equal to 4. 7 4 2 1 7 1 3 4. When you want to make 0 here, 1 14 minus 10, it is correct. Y equal to minus 10 and 2x plus y. Okay, we will see that problem later. Okay, let's go to one more question. Let's say we're having x plus y equal to 7 and 2x plus 2y equal to 14. We can observe here rank of A will be 1 and rank of AB will be 1. So it is less than number of unknowns. So here we will get infinitely many solutions. Why? Because if I keep here minus 4 minus 3, again minus 4 minus 3, it is solution. Again when I keep here minus 5 minus 2, again here also minus 10 minus 4, it is solution. So here we will get infinitely many solutions. Similarly, if I change the equation x plus y equal to y, 2x plus 2y equal to 4, we can observe here rank of A will be the 2 1 and rank of AB will be 2. So here you won't get any solution here. Okay, if I keep here randomly 0, then y will be the 7, and if I keep here 0 and y will be equal to 2. So when I substitute those two here, you won't get proper solution here. Okay, so it's nothing but no solution. So now we had an examples related to non-homogeneous. Let's see some examples related to homogeneous. Let's say x plus y equal to 0 and 2x plus 3y equal to 0. So what will be the solutions here? 1 1 2 3. So if you calculate the rank here, you will get 1 1 0 and 1. Okay, so rank will be 2. Again here you will get how many solutions? Only trivial solutions, that is 0 0. Except 0 0, you won't get any solution here. Similarly, if I change here 2, then rank of A will become 1. Then you will get infinitely many trivial solutions saying x equal to minus 1, y equal to minus 1, minus 2, plus 2, minus 2, like that. Okay, so you will get infinitely many trivial solutions. Okay, fine. Now we will see some 3x3 examples. I have some examples. Let's say we are having x plus y plus z equal to 3 and x plus 2y plus 3z equal to 4 and again x plus 4y plus 9z equal to 6. Now matrix will become 1 1 1 1 2 3 1 4 9 1 2 3 1 4 9 3 4 6. So now you are having this type of equation. So you can clearly observe that here first set there is no independency, right? So here it is except first element all are dependent on row 2, but this element is not dependent. So here you will get rank as a 3 only. Anyway, we will solve that one. Okay. So what is the first step in that? We need to make zeros here. Then how we will do that? So R2 implies R2 minus R1 and R3 implies R3 minus R1. So when you do that, R1 will be the same, and here you will get 0 and you will get 1 2 1, then 0 3 8 and 0 3 8 and 6 will be a 6 minus 3 3. Okay. Next I want to make here 0, that implies R1 implies R1 minus R2, and similarly R3 implies R3 minus 3 times R2. So it will be 1 0 make correct. So I need to multiply. Okay, correct 0 and minus 1 and 2. So here it will be the same, and here 0 0 2 and now do with 3 here 0. Okay. So what is the next step here? You can apply any row operations, column operations, whatever it is. So if I want to make this one as a 0, I can apply C1 implies C1 plus C3 implies C1 plus C3. Then 1 0 0 and 0 1 0 and 0 2 2 and 2 1 0. So from this matrix we can say x equal to 2 and z equal to 0 and y plus 2z equal to 1. It is nothing but y equal to 1. So 2 1 0 becomes the solution for this equation. You can substitute those things here. 2 1 0 3 again 2 1 0, it is nothing but 4. 2 1 0, it is nothing but 6. It is satisfied. In this way you can solve system of linear equation solutions. We will see some more examples and we will finish this concept here. Then we will move to eigenvalues. Let's say you are having matrix. Okay. X plus y plus z equal to 6 and 2x minus y plus z equal to 3, x plus 2y minus z equal to 3. Now you need to find the equations x, y, z, and first you need to know rank here, right? So 1 1 1 6 and 2 minus 1 1 3 1 2 minus 1 3. By seeing we can say there is no dependency. So let's try. So first we need to apply R2 implies R2 minus 2 times R1 and R3 implies R3 minus R1. So what is the next step here? So R1 will be the same, R2 will become 0 and minus 1 minus 2 minus 3 and again here 1 minus 2 minus 1 12 3 minus 12 is nothing but minus 9. Similarly, next step when you subtract from R3 to R1, so it is nothing but 1 minus 1 0 1 and minus 2 3 minus 6 minus 3. Okay, now are you having this solution? Now again, so what is the next step? So you can make this as a 0 and this term as a 0. by R1 implies R1 minus, I can use R3, it will be the simple, right? And R3 implies 3 times R1 R3 plus R2. Okay, so what will happen? 1 0, and when I do this here 3 and here 9. Similarly 0 minus 3 minus 1 minus 9 will be the same, and when I do here 0 0 and here it will be 6, no? Minus 6 minus 1 is nothing but minus 7, here minus 9 minus 9 is nothing but minus 18. Okay, so now from this row I am getting z value as a 18 by 17. Okay, before that we can try one more step. So when I apply this C3 implies C3 minus 3 times C1, then what I will get? I will get z value, I value, x value also, right? 1 0 0 and 0 minus 3 0 0 minus 1 and 0, it will be the same, it will be the same, 9 minus 9 and minus 8. Okay, I don't know what happened. Okay, so here z will be 18 by 17 and x will be the 9. What about y? And minus 3 minus 18 by 7 equal to minus 9. Here y will be there, and minus 3y equal to minus 9 plus 18 by 7. So here minus 3y equal to 7 9 63 minus 63 plus 18 by 7. So here what I will get is 63 minus 8 is nothing but 5. 5 minus 1 4 by 6 minus 3y equal to this much. Okay, 7 5s are 45. So y is nothing but 5 by 3. I don't know whether these are correct or not. We need to substitute those things here. So let's try here. So x we got 9 and y we got 5 by 3. What about z? Z is 18 by 7. Okay, 18 by 7. So LCM will be the 21 and 21 9s are 189, and similarly 7 5s are 35. Oh, we have done mistake here. So minus 45 by 7 will be multiple of 3, 15. So it's nothing but 15 by 7. Okay, y value will be 15 by 7. 15 by 7. Okay, so then what will get? 7 63 plus 15 plus 18. Okay, still we won't get the answer. Let's try this in our calculator, then we will see what are the mistakes we have done. Okay, so it will be there in lecture 6, I think so. So we got 3 cross 3 matrix, x will be the 1 and y will be the 1 and z will be the 1. And here 2 minus 1 and 1, and again here 1 2 minus 1 and B will be 6 3 3 and analyze the rank and steps. So here you can see we have done different methods, but you will get rank will be 3 and you will get unique solution here. I know that. Here solution 1.2, 2.14 and 2.57 something. What we are getting here? What about x value here? X value we are getting 9. How? Okay, there is some calculation mistake. You can check with that calculator. If you have any doubts, you can come.